All right, good morning, everyone. Welcome to our interview and expert as part of a series within our education class. My name is Michael Ingram, and today we are interviewing Dr. Winn. As I briefly said, my name is Michael Ingram. I'm the interviewer in today's interview and expert. Um, I've completed an undergrad in physical education with a minor in French, and I'm currently studying to be a technology education teacher. Uh, and thank you, Dr. Winn, for taking time this morning to be with us.
So I've taught design and technology to 11 to 18-year-olds in England for about 25 years. When I started, computer-aided design had really just started to come into schools. I developed an interest through a competition that the school was doing in CAD, but I was getting very frustrated with the way it was taught. So I then used that as my research for my PhD. It stayed very much in the forefront of my mind to try and improve the way CAD is taught.
Awesome, thank you. So, to begin the line of questioning, the first interview question we have today is how can we, as pre service teachers, assess students' proficiency with various digital tools and technologies?
So, assessments always got to really come down to progress, but progress, I think, quite often people seem to think is just about the outcome, and it's got to be more about more than the outcome, and needs to be about other things such as their willingness to have a go at something, how independently they work, whether they're able to identify the key words and know what they mean. All of those things sort of build up to their proficiency, not just actually whether they can complete the task. Particularly if they can recognise that that they've made a mistake or why something isn't working. That's progress. And so I think you really need to not just have outcome, but have different titles to your assessment. So you could say have a mark out of 5 for independence, problem solving and keywords. And when the outcome can't be assessed, then it's down to questioning and observation to be able to make that decision on what they've achieved. Outcome does have to play a part, particularly in the older students, because that's your aim, is to get them to be able to do something with the technologies. But there should really be a scaled option for the outcome, because otherwise what you're going to do is hold back some that are going to fly with it, but perhaps overface others that are quite nervous about using the technologies.
Right, that's really really insightful to focus on not solely the outcome and but how we can get students there and the process to where we reach that outcome and addressing miniature steps along those ways. Um,
Yeah.
in what ways has the COVID-19 pandemic changed the landscape of technology education?
I think it's had an impact for my generation, particularly because previously you would have seen teachers of my age and older who sometimes were quite fearful of technologies, and it was new and they wanted to stick with what they knew. And I think because you had to be involved with technology over that COVID period, whether it be Zoom meetings, something like this, Zoom meetings or Teams meetings, setting assignments, teaching your lessons through it, it became a lot more normalized. And because I think the teachers became more confident and comfortable with using it, then so did the students. It was just normal. It wasn't something additional or separate, and they could see why, the purpose for needing technologies through having to use it to actually learn. I think the ability to be able to access, say, YouTube videos to help themselves, so they can go and look for things, has always been there. But I think they're more used to being able to go and find that for themselves. So the younger students, anyway. I think older students, it's a skill that's learnt. But younger students are now more able to do that than they were before, or more aware of it to help themselves.
Right. I think COVID it's definitely had its impact, especially surrounding the technology education field. I know within my undergrad as a physical education student, we do practicums, which is essentially a 10-day placement within a school solely under the physical education teacher. And this was just shortly after the COVID pandemic and the Schwartz return to school process. And I know a lot of teachers definitely lacked in confidence as well as competence within the technology that was used during the COVID timeframe. So I think it's definitely important and crucial that we recognize that there are teachers that do lack in confidence and competence within this, and really try to educate everyone on the technologies that are out there and resources that we do have available. Going into our next question, how do we effectively balance teaching traditional skills like designing and making with the need to incorporate digital technologies?
I think you've got to consider why you are teaching digital technologies and design technology. For me, the purpose of my subject is to give students life skills. So they need to know how something is made, what it's made of, all of those things to be able to make a reasoned decision on what they are buying. Um, I want to introduce them to different careers. You're in work a very long time, and you should be doing something that you enjoy. And they don't necessarily know that a lot of these careers are out there that use technologies. Added to which, the technologies will change. So somebody that's starting school now, there might be a new job that comes out when they leave school, or their degree or whatever, and then you need to be able to make them aware of what is available for them in all areas, but also for leisure and mental health. So there's a lot of people that enjoy making and creating that help them as a hobby, and also with a mental health. So there needs to be a mix. You can't just say, right, I'm just going to teach CAD CAM because that's all we need. There needs to be the breadth. Some issues, however, with the design technologies in schools are costs and safety. So schools are starting to get a bit more reluctant to teach the traditional skills because it's cheaper to do it in a different way. And our education system only gives about 10% of the grade to the practical work. So there's a tendency to reduce the making time by using CAD CAM. But whilst this covers the exam requirements, what it doesn't do is cover the needs of the whole student. So there does have to be a balance. On the flip side of that is the computer programs that we're using come with a cost, and whereas it used to be free, where it's become they've become web based, and you've got data protection, and students need to have their own accounts. A lot of schools won't run the free programs anymore. So then it comes as for us, it's around about £5,000 for the program, but our budget is £1,500, so it doesn't quite work. So they both need to be done, and you need to work out how to fit that in, both with budgets, and to look at the whole student around. And how things are made. So a lot of things are made with CAD CAM these days. Everything, a lot of things are automated. They need to know about that, and they need to know how it comes. But also there are other things like hobbies and mental health, and being able to put up a shelf that things they need to be taught to be comfortable with using the traditional skills as well.
Very good. Yes, there's definitely a lot of exterior things to think about regarding that fine balance between traditional skills and digital technologies. Like you mentioned, budgeting within programs like that. It's definitely something that, as pre-service teachers, we need to think about going forward, and being diverse for all students and meeting their needs, but also meeting the needs of the curriculum while thinking about budgeting along the way. So we've talked about the CAD software quite a bit throughout this interview. So with that being said, what strategies can we use to introduce complex technologies like 3D CAD software without overwhelming students, but also without overwhelming the teacher, since like we've talked about as well, there is a difference in the confidence and competence around teachers with complex softwares like this one?
I think certainly there's scaffolding the content so that you've got a clear path ladder up in the skills. So you can start right at the bottom, but there are some people that might start a little bit further up that ladder to go up, and then it's baby steps right the way up. but it's also relating it to things they're comfortable with and familiar with. So, for example, teaching layering by using Play-Doh plasticine, modeling clay, to be able to see that how to layer things, for example, making it into a game with points, so it becomes a little bit less overwhelming. But also, I think having a resource that teaches you how to solve the problems is really, really good. So in one of the games I created for children to learn 3D CAD, there was it was called a Book of Magic, but essentially it showed them what mistakes were likely to happen and how to solve them. And even if you had a teacher that wasn't particularly confident, they could go through this with the student, like literally work through it point by point, which was really, really helpful to have.
Right, it's definitely good to see and recognize that mistakes are going to happen along the way, and start by scaffolding and ensuring or trying our best to ensure student success by slowly implementing higher skill-oriented things. So speaking on to mistakes and failure, what strategies can we as pre-service teachers use to help students cope with failure when working with precise technologies, and how can we ensure that student confidence does not lower but is continuously building throughout a lesson?
I think it comes back to the assessment that sort of we talked about at the beginning, because if you're only rewarding the outcome, then it becomes a big thing if something goes wrong. Whereas if you're rewarding how independent they are, or how willing they are to have a go, or that they've used the correct word, or if they've been able to um, uh, realize there's a mistake and try and solve it, even if it goes wrong. If you're rewarding those things, then they're going to be much more confident to have a go, and they won't see it as a risk because they can see it as learning, not just failure.
Right, I think it's definitely crucial to see students view those mistakes and view failures not as failures but opportunities moving forward to grow as an individual. Um, viewing not just student confidence but teacher confidence as well. What professional development opportunities should we as pre-service teachers seek out to enhance our skills in integrating technology effectively?
I think the thing that pushed me forward in learning CAD the best was actually getting involved in a competition. I don't know if you have it there because it is an international competition, but it was the F1 in Schools CAD CAM Design Challenge. And through that, the children would come up with designs, and then you would have to learn how to make those designs and how to get them to work and how to test them and trial them. And so it kind of pushed me forward for certain, but also you build up a lot of networks with other people. So you start to get contacts with other people that do exactly the same thing and are having the same problems, and you can kind of work through them together or speak to people that have actually solved them. So I would say definitely try and get involved in competitions. The students love them. It's great for the schools, but it sort of adds to your profile, but it also is a great learning process.
Yeah, I think it's definitely important to add some enjoyment behind technology education. You spoke on competitions, so I know here in Newfoundland there is a quite a big push on ROV competitions now among schools. We have an instructor here, Mr. Paul King, who does quite a fantastic job at implementing those within schools and pursuing those competitions as well. Um, so speaking on not just focusing on the implementation of technologies and how to make them, but also how to operate them amongst teachers. What methods can we use as pre-service teachers to encourage our own students to explore what the technologies are capable of and how far we can push the boundaries on technologies as opposed to just creating an operation?
Um, I think that showing students how things are made, so whether that be through videos, whether that be through inviting in external speakers, talking about possible careers, and getting like actual industry involved so they can see what is possible. is really good. But also going back to the competitions, they try and make them as industry standard as possible as a rule. So testing through CFD, for example, rather than just visual. And students wouldn't necessarily know that was possible unless we actually did it and tried it and saw it through that industry process.
Right, so showing students the industrial side of things and showing how the processes actually work can definitely provide great insight into our classes for that. So coming up onto our final question for the interview questions for today, what practical activities can we as pre-service teachers implement to help students keep a mistakes log effectively? So this was spoken about in the chapter mistakes log. Which is a great way for students to recognize those failures and treat them as opportunities as opposed to those failures. But how can we practically implement that within our classrooms?
I mean, we use booklets, so we've built it into our booklets, something like sort of like that. But we've got so there'll be a page in there that's got what mistake they've made, how they tried to solve it, whether that worked or not, and then just being able to note it, whether they've made the same mistake again, whether they've recognised that quicker, and if they write it down, then that can be marked.
Right, so providing students with a medium to keep things organized and keep things neat and tidy, and let them recognize when mistakes are made and have everything put together in a booklet is a great way for us to implement that within our classrooms. Thank you for that.
Yeah, and if teachers can see the teachers seeing that and the teachers marking it and are actually praising, like, oh, well done, you found that, you managed to solve that problem, or you noticed that problem, and that's getting praised, and they're more likely to start noting it and writing it down because they are seeing it part of learning, not as part of a mistake, part of failure.
Right, so using it as almost an assessment tool as well to help students recognize, okay, that is an opportunity that you've used to increase your knowledge and you actually succeeded from that failure.
Yeah.
Right. So moving into our audience questions now, we have a question from Drew Taylor. Drew asks, referring to the importance of task setting when teaching digital technologies and ensuring that tasks are achievable and differentiated, how important do you think it is to involve the students in the task setting process?
It depends on the knowledge of the student, because if they don't know what isn't possible, they won't be able to tell you what they want to do. However, quite often they don't see the complexities. So, for example, if you're trying to make components for a model car, and you need to get everything to fit, you need to get it to scale, and all of these things, then that's great, but it's unlikely to work. So, I would say yes, it's good to take student opinion and their own interests into account when you're trying to do these things, because you want to kind of pull them in and get them enthused and excited. But to a certain extent, they don't know what is possible and what is not possible.
Right, so it really depends on the type of classroom that you have and how students have developed within that class. Next, we have a question from Spencer Crane. He asks, do you believe there is a risk that technology could become a crutch, potentially limiting the development of other skills, like manual dexterity or deep critical thinking?
I think it is a risk, and it's certainly it's difficult to keep holding on to traditional skills, and just being able to do the basics. And we need skills. We need plumbers and carpenters and mechanics and all of those people within it. So you kind of need to keep in touch with that, but I don't think it'll ever totally replace it. But in terms of education, where you've got the problem with safety, health and safety, and you've got the problem with funding and things like that, it is difficult to try and keep hold of it and keep it going within the school.
Right, so again, there's definitely a lot of exterior factors when thinking about technology and continuing to develop manual dexterity skills as well. So another question that we have from the audience is from Michael Leonard Power. He asks, referring to when the students completed a 3D printed car and some of the students did not participate because their car was not done correctly, what do you think checkpoints to correct students' mistakes along the way could have happened to avoid this?
Okay. I mean, that wasn't my project. That was just something that I'd found within the research. But it's a tough one to answer. It comes down to how much time you've got. Because if you go in, it's fine to have those checkpoints, but how much time do you have to keep going back and assessing every single student within a normal class day, within everything else you've got to teach with it? So I think the best thing is not necessarily checkpoints, but have some standard components potentially that they build on, so that you know the sizes are correct. They've just got to adapt them, rather than sort of having to check each student's work constantly to make sure it's going to fit, it's going to work. But just have something they can build on, so that you've got a base, say for the car, and you've got a base for the wheels, and then they build on top of that, so that you know it's going to fit. You know it's sort of going to work.
Right, so ensuring student success by creating components that you cannot progress on further unless that component does indeed fit what is required for that car. Well, thank you for taking time out of your own day to spend with us today. That concludes the interview. And again, Dr. Winn, thank you. We really, really appreciate your time, and we hope that you enjoy the rest of your day.
Okay, thank you very much. Bye.
Thank you. Bye.